Hi Chad, welcome to another stream. How are y'all doing today? It is Christmas Eve for me. And we're back for some Advent of Code. We're gonna try and finish up before day 25 comes out. We have day 24 to do, which I looked at the leaderboard and it looks like a doozy, and we have to do 21 part 2, which I've been thinking about, and I saw a little hint. And I think I was actually on the right path when I decided to do the other 2 days first, so we'll come back to that one. Don't expect too many people to show up because it's holidays, but it's good to see you, JJMC, who was first, and the Endless River. How you doing? Welcome back. I guess we'll just jump into things because I want to get through these quickly, and it looks like day 24 is a doozy, so let's not waste any time on that. Day 00, day 24. Let's get into that. So I hope you all are doing well. I just got back from my brother's, where we had like a sort of snacky get together with my mom, which was nice. But yeah, let's jump into this. I looked at the leaderboard and it took an hour to fill up, so I expect this one to be a lot of work. And we'll tackle it. We got big coordinate things, it looks like. That'll be a fun one. Here's our sample. Never tell me the odds. Oh boy. That's a good one. Alright. Hailstone's position and velocity. Oh boy. Tiny Small 69 says having a peek because it's 1 a.m. already. Oh! Good to see you again. Welcome back. Alright. Position and velocity. Cool. Till Meggles, thank you for the follow. Welcome. Hopefully you're doing well. Reminds me I need to open up my little dashboard. Oh, floating point number. That is something we don't see in Advent of Code very often. Okay, it's all just positions and stuff. In this example, look for intersections that happen with an X and Y position. Each at least 7 and at most 27. In your actual data, you need to find a much larger test area. Okay, so we'll have min and max there. Alright, disregard Z entirely. Okay, that seems fine. So, we're gonna have input to here that's also... what was it? Low and high. So int equals some big fucking number. High int equals this. Oh, not what I wanted. Those are some big fucking numbers. Are making me nervous already. And the low and high in the test one is 7 and 27. And the example expected is 2. Disregard Z entirely. Okay, well, I wonder what part 2 is. How many of these intersections occur within the test area? So ignoring the... What the fuck? Okay. Position, whatever. How likely are the hailstones to collide with each other and smash the tiny ice crystals? Consider only X and Y axis. Ignore the Z axis. Looking forward in time, how many of the hailstones' paths will intersect within a test area? They don't have to collide, just test for intersections between the paths they will trace. Okay, so it has to be in the future paths. Check all pairs of intersections. This sounds easy. Is this not easy? Grogan's hello. How you doing? Silly Laird, how's it going? Meat Sauce is also here. Control Shift C Madness, I remapped it since I always open the dev tools. Terminal F10 was mapped to the burger menu control plus open some weird GTK emote thing. Oh, you can change that because I keep doing that over and over. Nice. Yeah, so this just kind of seems like system of equations. Yeah. Although, how do I represent this as an equation? Alright, well, let's just parse everything first, I guess. Which day am I on? This is 24. At least for the example, it's just can simulate it. We know the bounds. Does my first point comma, I don't think this one works because no, it would work. Okay. So that's the parsing out of the way. We have to figure out when a hailstone intersects with another one. And we only consider X and Y for the first part. So that's just intersection of lines. So what? We have X is equal to X naught plus Vx times T, and then Y equals Y naught plus Vx times T, and then so we have like these three equations. Although for part one we don't have them, we don't have this one at all. And then for pairs we have two of these, so we have this is also equal to x1 plus vx times t. Is it just crossing the paths at all? They never intersect. Is it their paths, or do we want collisions? Oh, did I do VX? Yeah, I'm using PyPy for admin of code just because it goes faster. Yeah, this is clearly Vy. Okay, so given this, what do we have? Let's just, since we have an example here. So we have the x equation of x equals 19 plus negative 2x times t is equal to 18 plus negative 1x times t. So this is, I guess we could just say this. 19 minus 2x equals, or 2t equals 18 minus t. And so negative t equals negative 1. So t is 1 when those are the same. And so at t of 1, doesn't sound right. They have 17 and 17. Is that what the example said? That's when they have the same x position. 312 got slower again compared to 311? It's supposed to be faster still. 313 will be slightly slower. Fuck, is this possible? So what happens at this? X equals 14.333. So 14.333 is equal to 19 minus 2t. I don't know why I wrote x here. So that would be 14.333 minus 19 over negative 2. So t of 2.335. So what is 13 plus 1 times 2.335? It says 15. So that makes sense. That's the position. What is B? 18 minus 2.335 is a different position. Is it just that their paths will cross? So it's for some t they will exist? I don't really know how to represent. Oh, I guess this is a slope. So you can say y equals wait, how do you turn points how do you turn points and velocity into a line again? So we know that what 19 equals slope is I'm blanking here. This is basic geometry and I just haven't done this in forever. It's change in y over change in x. Okay, so 1 over negative 2 times x plus times what? 13. No, y x 13 plus c. And so 19 equals negative 13 over 2. So c equals 19 plus 13 over 2. So the original equation equals negative 1 over 2 times x plus 25.5. That's one of the equations. And then the other equation is (19) equals negative 1 over negative 1. 1 times x plus is... Oh, I have it up here. X is 18. So c equals 1. So we have y equals x plus 1. And we have y equals negative 0.5x plus 25.5. And then to solve the system of equations, you have what? 0 equals 0.5x. Oh, is it subtraction or addition? I don't remember. This is basic geometry or algebra at this point. I'm struggling with the algebra part. Solve system of equations. I want to know how to do it, not the. Pretty sure it's just subtract the two. You treat them as equal. Oh my fucking god. I am actually on, yeah. Oh, you can do it with substitution. Yeah, that works. Okay. So then you have, but there's like a cool, neat subtraction way to do this too. So negative 0.5x plus 25.5 equals x plus 1. So we add 0.5x to both sides, then we get 25.5 equals 1.5x plus 1. Subtract 1, 24.5. 24.5 divided by 1.5. That's a different number. Shit. It's similar to the numbers. Maybe I just wrote this down wrong. Let me try this. Let me try this one more time. I'm the newest Avenger. What does that mean? Okay, so y of 13 equals 1 divided by negative 2 times 19 plus c. So this is negative 0.5 times 19, which is negative 9.5. So c is equal to 22.5. So one of the equations is y equals negative 0.5x plus 22.5. Okay, that's different than what I had before. That's equation 1. Equation 2 is y equals... Which day has been the most challenging so far? I haven't finished day 21 yet, just because I got spooked, but I think it's actually easier than I think it is. So this second one, 19 equals 1x and 18 plus c. I did this one right, so c is 1, so y equals x plus 1. And so then if we solve this again, Kag said hello, how you doing? Good to see you again. There's like a neat way to do this with just subtracting these or adding them together. I think it's subtraction. So negative 1.5x is equal to 11.5? Is that right? So 11.5. No, that can't be right. Do it the right way. X equals 1, or x plus 1 is equal to negative 0.5 x plus 22.5. So we subtract 1 from both sides. We subtract 21.5 divided by 1.5. 14.333. Okay. Alright, so that's how we can do these. And then we need to figure out whether that time's in the future or the past. F says, I feel bad when I see some competitive programming god go through these in minutes. Well, they practice the stuff and they're you know, they're good at it. Which is, you know, not hard, so to speak, but okay. Other hailstone. Okay, so we have to figure out if they intersect in the non-Z and positive T. Okay, so first we have to solve for each constant. Well, we have to find what the actual equation is first. Okay, so y equals mx plus b, so we have self.y0 equals self.vy over self.vx times self.x0 plus c. So c is equal to self.y0 minus this thing. Oh, fucking A. I don't know how to do 3D. I don't know how to do 3D equations. At all. So I'm gonna have to figure that out. That's gonna be part 2. Almost certainly. Okay, so we also have c equals other.y. Other.y minus self.vy over self.v or other. That's how we get that other C1. Solving equations with 3 unknowns. Well, we have velocity. I just don't know how to turn them into a system of equations. Like y equals mx plus b obviously comes from some way to do this. Oh, I guess you have what? X equals vx plus x0, and then you can say that 0 equals or wait, x equals vx times t plus x0, and then you solve for t. So you say that t is equal to x minus x0 divided by vx. And then you solve the y equation as well, so you can say that t is also equal to y minus y0 divided by vy. And then you make them equal. Y minus y0 over vy is equal to x minus x0 divided by vx. And so then you say multiply by vy, get y minus y0 equals x minus x0 times vy over vx. And you can actually plus y0 to get that into here as well. And then then you know, distribute this across here. And so you get vy over vx times x minus vy over vx times x0 plus y0. And so that's how you derive 2D equations. I guess in theory you would have two sets of equations for 3D equations. Hey Monkey Man, hello, how you doing? What programming language is this? This is Python over here. This is just me dripping out the derivation of linear equations. All right, so then we need to do this part up here, which is that. But how do we get to this final value here? We had these two equations, so we had the two c's, and we had the two slopes. And so the x value was this minus this. Or I guess this minus this over this minus this. No. How do I get negative? This minus this is negative 1.5. And this minus this is 21.5, but we need it to be negative. It's like they subtract each other in the opposite direction. I guess that's fine. So x equals what? So we have y equals m1 times x plus c1, and we have y equals m2 times x plus c2, and so m1 times x plus c1 equals m2 times x plus c2, and so then okay, so that's how we get x. So x is, I guess we can write this one out. M1 is equal to self.vy over self.vx. Okay, so x is equal to other dot c2d minus self.c2d divided by self.m2d minus other.m2d. That's the x. And then the y. I guess we need to return float. So this will be time this will be collision 2D or none, because I guess there are going to be some that cannot work. So from this we can figure out the time. So t equals x minus x naught over vx, so we can just plug that in. T equals x minus self.x0 divided by self.vx, and so then y is equal to self.vy times t plus self.y0 and that's our collision dxy. Yeah, I think so. Let's try it for the examples. I don't know how none is gonna happen yet, but I'm sure it will be apparent. I'm pretty sure the REPL I need to do this. So when we need you. What do you mean unexpected indent? God damn it. Okay, so we get our example ones. Do it again. Okay, so H1 is equal to hailstone 19, 13, 30, negative 2, 1, negative 2. H2 is hailstone 18, 19, 22, negative 1, negative 1, negative 2. H1 dot intersect non-z positive t. Actually, we'll just say non-z. We don't have to do this, but well, we already wrote it out. Hailstone has no attribute y. That's supposed to be y0. Damn. Where did I write that out? Yeah, it's probably y0. Fuck, I deleted the code for it. Well, I hope that's right. Fucking A. tab complete. 40.3, 15.3. Thick. Alright, let's try these two since they're not supposed to intersect, so I think they will divide by 0. I hope. 18, 19, 22, -1, -1, -2. H2, 20, 25, 34, -2, -2, -4. Hooray! We get a 0 division. Okay. So that's what happens when they don't collide. Okay, so that gives us this. It's parse int comma? Maybe parse. Parse numbers comma. What day is this? This is 24. Because I was gonna say 25 and then I was like, wait, I can save this. Okay, so we need to find ones that are in the future and in that little box. Okay. We need to compare every hailstone with every other hailstone. If collision is not none and collision is positive and low less than or equal to collision dot x less than or equal to high. Collision. Why did I not call it T? Did I call it time? I did. Oh, syntax error. Title of the terminal says day 24. Yes, it is 24. Indeed. Thank you, Flintstone. Alright. It seems too easy. Especially because we got something wrong. This is all of the comparisons. So, do they call him A and B? Oh, we have to find the time for both of them. Not just one of them. Okay. Okay, so t0 equals that. T1 equals x minus other dot x0 divided by other dot vx. Should probably compute. Well, actually, say that. Cool. That wasn't too bad. R2 is going to be 3D and no bounds or something. Well, it seems extremely unlikely. Should you throw it just right, you should be able to hit every hailstone in a single throw. You could use the probably magic winds to reach any integer position you like and to propel the rocket any integer velocity. Plus the z-axis. You throw the rocket times 0. Where do you need to be so that the rock perfectly collides with every hailstone? Due to probably magical inertia, the rock won't slow down or change direction when it collides with a hailstone. Oh, holy shit. Oh boy. The times the other rock needs to be at this. Adding these 3 produces 47. Okay. So it's a big ol' fucking system of equations. So how do I go about doing this? I think we need to figure out how to make a 3D equation based on t, I guess. Like, what does even a 3D equation look like? I'm not even sure. Let's try and derive one. We don't need a terminal for this because it's not going to be helpful. So we know that x equals x naught times t plus, or vx times t plus x naught. We know this. We know that y equals vy times t plus y naught, and we know that z equals vz times t plus z naught. We can solve for t in each of these to get t equals what, x minus x naught divided by vx is equal to y minus y naught over vy is equal to z minus z naught over vz. But this, how do we stick this all into an equation? is the question. So we can get one part of this by doing this, by saying that x minus x naught over vx equals y minus y naught over vy. I don't know. How to represent a line in 3D algebra. Equation of a line in 3D. Mathematics stack exchange, oh boy. Vector form, parametric form, yeah, symmetric form. In my opinion, the symmetric form is the most useless one. I mean, the vector form is a thing, I guess. You can describe line as the intersection of two planes. Where f is a nice function. Yeah, this is what I figured. And we do have kind of two equations per line, and we can sort of solve those. Maybe? But we need to solve them for everything. Anyway, we get rid of low and high. Those don't matter anymore for this. So let's think about this in a different way. We know that we have some. We know we have those for each thing. We know we have our rock, which has an initial. We'll call it x prime, because that sounds cool. We know at some point that for some t, this, like all three of these are going to be equal to the same equations for this. And we know that has to be true for all of these things. So I think we can just slam all of these together. Well, they'll be different t's. Reborn TTV, thank you for the follow. Welcome, welcome. Hopefully you're doing well. So we know for some t, for x0, x00, great. We know that for some t, this has to be true. What? X equals vx prime times t plus x prime. So x prime. What is x0? Oh, this is just nx. So x we know at some t these x's are the same, right? So we have x minus x 0, 0 over vx 0 is equal to x minus x prime over vx prime. And so we can make an equation for x. And then we can just solve it with z3. We can just cheese it. Do we cheese it? I don't know. So we have let's see, x times v x prime over v x 0. Engineer trying to code. Thank you for the follow. Welcome, welcome. Hopefully you're doing well. Minus x 0, 0 times vx over vx 0 is equal to x. So I feel like I'm making this worse. This might be the one where I just cheese it with Z3. Okay, so there's gonna be integer positions, integer velocities. Song loops. Skip it. Yeah, I'm gonna cheese it with Z3. I think this is gonna be fun with Z3. Just the magic of describe the problem and have it answer it for us. And if we have time, we'll do it the not Z3 way. Okay, so oh god, there's so much stuff in Z3. Let's not do that. Is there a Z3.real? Yeah, there is. Okay. Okay, so we want a solver. We need to figure out our okay, so we know that there's going to be some t where these collide. These are conveniently all integers. Are they always integers? We don't know. We'll just say it's a real. And so at that t, we know that rock x0 plus rock vx times t, rock x0 plus collision t times rock vx is equal to hailstone dot x0 plus collision t times hailstone vx. Yeah, so we just know that for each dimension. And then I don't remember how to use Z3. Oliver dot, was it model check? Yeah, so we get 13, 14, 15, wait, no. X0, 24 plus 13 plus 10, 34, 40, 34, 47? Okay, yeah. So what does that do for the actual input? Oops. Is that too big? Do I have to actually solve it out? Computer go brr. Come on. Come on, Z3, don't fail me now. Damn, I might not be able to cheese it. Because how many hailstones are there? 300. For 5, it took a couple seconds. It'll be 60 times longer than that, so it'll probably take a couple minutes. Unless it is exponential in nature. We're gonna give it a little bit of time here. You could also probably write out all the equations and then solve it by hand. I'm gonna let that go while I sort of think about this. Okay. rock x0 plus t0 times rock vx is equal to hailstone nope, h0.vx. So we're gonna have a whole bunch of these equations for a whole bunch of free variables. This doesn't reduce the number of variables. Also, this hasn't finished yet, which is making me nervous. So this should be T2. Yeah, like somehow we need to be able to cancel things out to determine the values. So for 3, it looks like this. We have the z direction as well. I guess this is nice because we can figure out, like, we have t's here, we have ways to cross references, so we can actually solve this. So how do we solve this is the next question. Because this is in terms of t, these are our unknown variables. And so we can solve each of these in terms of t, and then substitute them into each other. Let's just say there's only 2 rocks. How do we do that? And let's just say only 2 directions. Alex Terra says happy 25th. We're not quite there yet in this time zone. I got 4 more hours to let Z3 solve this, or to figure out how to solve it ourselves. Okay, so let's solve these in terms of each t. So we have this one. We're gonna have what? This minus rock x0. Then signing off, 3am here. Merry Christmas and good luck. Well, thank you for stopping by, Meat Sauce. Appreciate you hanging out. I wonder if solver was the wrong thing to use here. Because I think there's infinite solutions, and it just gave us 1. Because you could keep adjusting the t's. So maybe we give it a constraint that t has to be greater than or equal to 0. Pastor Gammer, thank you for the follow. Welcome, welcome. Hopefully you're doing well. I'm gonna cancel this. Let's say that PowerSP says, haven't started yet. Are people supposed to learn a theorem proof for today's puzzle? No, I'm trying to cheese it. I'm trying to cheese it without having to think about the algebra. Actually, let's... That's how slow it is for... That's how slow it is for that. Kind of curious if I just like kill a bunch of these lines. Does it get a solution faster here? I wonder if it says that... Like, I wonder if the collision times are always going to be integers. Like, what if we change this to int? It certainly finds an answer. These seem way too large. Let's see if we give it the full input. So that works. What is this? Oh. Does it let me do this? Oh no, it doesn't. What if I do... How do I get the actual value out of these? Gamchiga Lolo, how you doing? As long. Yeah. It's definitely cheating to use a solver, but well, it's not definitely cheating. It feels like cheating to use a solver. But I'm gonna start with this solution. Very carelessness, preparing some turkey. Nice, nice. Day 24 part 1. Day 24 part 2 with Z3. But let's continue to like try and solve this out, just because I want to see if I can get there. So we also know that this is going to be equal to this, and in the Z direction as well. But we still have 3 free variables here, or 6 free variables here, which is not great. But we can add in another set. Wait, do you even need all the rocks? Did we add in another set of these? Like we know this is true for that. We also know at oh fucking A. We also know that this is true. And so we can solve for, I don't know, one of these variables. Yeah, like if we turn this into an equation in terms of rock x0, we have this rock x0 also. Like we can basically get, but this is a 6 variable equation. I don't know what the fuck to do with that. I'm gonna come back to this, and I'm gonna look at 21 part 2 because I didn't finish that one. But I think I was fairly close. So let's shelve this for a sec. Yeah, I cheated a little bit, but I don't know. I think using a theorem prover is kind of cool, and showing the power of it is nice, but a little bit cheesy. Actually, let's see. I would have been close to the leaderboard, I think, with that. Given what I read earlier. Oh, not quite. I would have missed it by 20 minutes. But it would have been funny. Alright, so let's go back to day 21. Which is this infinitely expanding thingy thing here. And I wanted to look at how these numbers increase, because I think I think that there's a pattern that I'm just not seeing, and then looking at the differences between how many numbers there are, will help me understand that. But I gotta fill up my water, so I'm gonna do that real quick. I will be right back. Hello, we're back. Ivan Via, thank you for the follow. Welcome, welcome. Hopefully you're doing well. Okay, so I was thinking about this a little bit, and I think my guess is that we will find some sort of pattern, and my intuition here is that things will spread out roughly in a diamond shape. Maybe less so on the example input, but when I looked at my actual input, there's these big chain or big like, where's the S? Yeah, there's these big kind of like lanes outwards. I think it'll roughly expand in a diamond pattern. So I'm hoping to see like a pattern in the counts for how many it spans, and then we will hopefully be able to do some other stuff here. Oh, I'm no longer making these assumptions, so we're fine with that. I'm gonna turn this into a little helper function. And we don't actually know. Oh, we do have numbers in here, yeah. Compute stir steps int, and we're supposed to compute it for this extremely large number. So my hope is that we find a pattern, and then with the pattern we can figure out what it's supposed to be. I'm actually going to put this in a little text file just so we can run this without having to muck around with PyTest. Let's just go up to 100. Compute s steps equals I. So this gives us a bunch of numbers, and I want to look kind of at their differences. Okay. Interestingly, we see like this little... Oh, that's... What is the length of this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Six, 7, 8, 9, 10, 11. That's interesting. That looks like it might be a pattern. Let's step this out some more. Do we see like kind of small one, then kind of small one, then much bigger? Small one, kind of much bigger? Yeah, okay, so we do see a pattern here. It has a periodicity. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I bet that's the width of our input or the height. Is our input square? Ooh. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, our input is square. It has a periodicity of 11. So that sort of makes sense. When does this cycle start? Kind of hard to tell. It looks like it starts there, maybe? Small, bigger, bigger. 5. What does that mean? I guess we could just subtract 11 from up here. Or a number, a multiple of 11 from... I mean, this is one of the parts that it looks like it repeats on. So if we subtract... I don't even know when it starts repeating, though, is kind of the problem. When is the cycle? My guess is that it's when... either when it overflows, or... Like, I think we might be able to... let's see. So we know a few points in here. I'm guessing if we saw when I plotted it in Google Sheets that it was quadratic, or it looked sort of either exponential or quadratic. Like roughly parabola shaped. I'm gonna see if we can assume it's a parabola. Let's take a couple of these points here. 87. I'm gonna just try the ones that are periodic and not the rest of them, because I'm guessing that we basically have 11 equations here. 87 is 49, 46, and we have, what's the next one? 98 is 6301, and 109 is 7934. So we have y equals ax squared plus bx plus c. That we know that these three things match that. So we solve for a, b, and c, I guess. $49, $46. Oh, we need. I'm gonna guess it's an int. Solver.add 49, 46 is equal to a times 87 squared plus b times 87 plus c. Eight. Unsat. Maybe these are reals. Oops. Well, that's satisfiable. Okay, so let's use this model and see if we can get the next number in that sequence, which is going to be 120. So we would have oh, this is looking good. This is looking good. This is looking good. We have what? 139 over 121 times 120 squared plus this times 120 plus this 98.45. Is that what we get for 120? Oh, we don't see it. We didn't go far enough. Ugh. A little bit farther. Satanic Pope, thank you for the follow. Welcome, welcome. Hopefully you're doing well. So 120, we get 9497. That is not the value that I expected. Maybe we overfit our data. Where's the next small one? That should be here. Oh, did I write down the wrong numbers? I wrote down the wrong numbers. Where did I get these numbers from? That one I wrote down correctly. 98. I wrote down correctly. 109. I wrote down the wrong number. What the fuck? How did I get this wrong? 7818. So let's try this again. Uh, 4946. 301. 7818. Oh, except we had the old number. 109, and then we'll fix the number here. Okay. Much different numbers. Let's plug those in. 120 squared plus these be quadratic times 120 plus u 9496 dot a bunch. Lofke says another ASA day, another day of anything make my Python skills feel insignificant. What was the number we expect? 9497? Plus. Who the fuck is it? 120. 9497. Okay. Okay. That's cool. So we should see a pattern. Remember some of this quick counting? Oh no. This song is looping as well. Okay, this is great. This means we can use quadratic fitting. I don't actually know how to do quadratic fitting. How to derive a quadratic fitting. Even 2 points and no vertex. Don't you need 3 points? I'm pretty sure you need 3 points. Even 3 points. Gives you a system of 3 linear equations, one for each point on 3 variables, which can then be solved by standard methods like row reduction. Okay. That seems fine. Okay, so let's assume we have 3 points and substitute them in here. Actually, we kind of already did that. So we have this. D falls away if you derive because it has no X associated with it, says Mario. Oh, a 3-stream watch stream, and this is your first chat message. Welcome to the stream. Has no X associated with it. I don't know what that means, but that seems fine. I don't know. I don't know what you mean. But here's our system of linear equations. I don't remember how to solve systems of linear equations. with more than 2 variables. um, I guess this would have been helpful for 25 where I cheesed it. Alright, we're gonna relearn basic algebra. I'm pretty sure it's just like you line them up and eliminate x by adding the first two equations. We've created a new 2x2 system. We solve for z by adding those. Oh, okay. So So I guess let's just write these out as numbers. 87 squared is 7569. 98 squared. Nine six oh four 1881. Okay, so what is this subtracting the two equations thing? Or adding the two equations? Okay, so we can convert one of these into the other by multiplying and then subtracting them out. Because we know that this is equal to this. And so we can multiply 0 by 2 and multiply this by some number. And it still holds. So if we multiply this by -1, we can eliminate c. So we can say that -a minus b minus c plus this. And so then we can say that we have what? A times 74569 plus b times 87 minus 4946. Except we need to subtract out this bit here. We have -2035 A minus 11B plus 1355 is equal to 0. And then we can do the same thing with this one here. So we could say that 0 equals 2207A plus 11B so we got this equation. So then we can slam those two together to get A. We get 0 equals 172 times A minus 267. So then A is equal to 267 over 172. Is that what we got over here? That is not what we got over there. We got 81 over 121. What? Did I reduce this wrong? Yeah, those are different numbers. Fuck it, we write part 2. Yeah, I guess we can just ignore the actual derivation because I can just use the solver for it. Oh, but we still need to check whether this holds for the other problem. And how long is 131? So we probably have to do a lot more steps in this. Let's set it to 400. Oh, and this is gonna do a whole bunch of duplicated work each time. It's gonna be kind of slow, but that's fine. Let's just try it. So we expect a period of 131. I don't exactly know when it should start. Intuitively, I feel like it has to start after it's processed at least the first thing, so when it bleeds onto the next one. It really slows down out here, doesn't it? That's because we keep doing the same work over and over and over. Really, we could do it in a different way. Let's actually stop this and write this in a better way. Okay. Let's just do, what did I want to do? 400 here? And then after each step, Grinding to a halt, indeed. Go back to here. Oh god. Oh, it shouldn't be steps, it should be I. Why is it plus 0? Yeah, so this goes a lot faster through a small input as well. Where is our little pattern? The fuck? Why do these numbers look different? What were some of the numbers we had before? 87. Did I not pass input small into this? Have I broken the code? Oh yeah, here we go. I must have scrolled up too far. Yeah, okay, so this still looks good. Oh, we can use our equation to trace backwards to figure out when... No, we can't figure out when it starts. How do we figure out when this pattern starts? Motivate Matt, thank you for the follow. Welcome, welcome. Hopefully you're doing well. If I had to guess, it starts after, like, my intuition on the input. Small? Oh, we're in the wrong day. That is... Alright. My intuition... is that we're gonna walk outward to the edge, and then everything after that should look like the pattern. Because as soon as we get to another one, we're really just repeating this like diamond path going that way. Roughly a diamond. So my guess is that after 1, 2, 3, 4, 5 steps, it's gonna start repeating. So is it after 5 or is it at 5? Unclear. So let's try and find an equation with this plus 11 and see if that one repeats. Otherwise, we'll try this one plus 11. Actually, let's write a little thing. Points equals this. Let's just say tuple int. And we'll get back ABC. Y equals A times X plus B times X plus C. Insert solver dot check is C3 dot set. Then how do we get out the We get out the... I think we want to get out fractions, not floats. There. So that we get back integers eventually, rather than weird float numbers. Let's try the one that we already knew. These three. Did the damn thing go? Here it is. Insertion error. Uh, 87 4946 98 6301 109 7818. What the fuck? Is this not exactly what we wrote in our little terminal doodad here? What? Wow, so clutch! I didn't know you streamed. How you doing? Welcome to the stream. Welcome, Raiders. How are you? What's up? What are you up to? Yeah, what did I do here that's different? Those look fine. Is it the order that I declared them in? Motherfuck, it's the order I declared them in. I didn't know that. Seems weird. Oh, maybe it's not that it's identity. It's equals equals. Whoops. That means my day 24 has the wrong thing too. Maybe I'm just riding my bike on Zwift. Oh, I remember now. Nice, nice. Yeah, you do BC streams. We want equals equals. We gotta make sure this is actually executable because I just did it interactively. Still spinning my legs for some reason. Oh, that's cool. Yeah, we're gonna rewrite the history a little bit there. Okay. So do I even have to do that? What is a... Oh. A mod dot what? Oh, we got numerator. And denominator. Is there an as fraction? That would be fucking sick. As fraction, nice. Fractions are fraction. Oh, that's perfect. This is actually not int, it's fraction. Fraction. Return model equals solver dot model a dot as fraction Model b.as fraction, model c.as fraction. I guess we could say return. No, this will type check better, even though there's a shorter way to write that. Okay, so given that, we wanted to see when the periodicity starts. So I'm guessing that it starts at 5. So let's try putting in something. Let's try 5, 13, and plus 11, so 16, 129. Plus 11 would be 27 and 427. And then let's plug in 38 for x. So a times 38 squared plus b times 38 plus c. Get 907 for 38. That's not correct. Okay, let's try 6 then. Get 6 and 16. We get 17 and 145. And we get 28 and 460. Let's try and plug in 39. We get 961. 39. Also not right. Okay. Okay, so my hypothesis is not correct. I guess we'll just keep trying them and see where we get the right value. It's kind of slow to do though, and computers could do this much faster. But fuck it, we're already here. We'll just do it this way. 18 and 165, 29 and 491. 40,000. Okay, that's also not right. Okay, I'm gonna adjust this. I think my next guess is it's going to be I don't know. How's the AOC going? It's going alright. We're doing 21 part 2. I found a pattern. I've been able to extrapolate if I start far enough out, but I need to figure out when I can start extrapolating. Do I need to figure out when I can start extrapolating? I could just compute further and further out. Like, I wonder if it's more than 11 out I could find it. Lucas Ibel, thank you for the follow. Welcome. Sorry if I mispronounced your name. Let's try from 11 onwards, because that's the width of the periodicity. Let's say 1163, 22, 61, and 33, 644, and so then let's try 44. 34 or 44. No, it's still not that one. Am I looking at the right data? Yeah. Weird. Okay, let's try after that then. Let's try 12, 23, 34. 34, 23 is 294. Then 34 is 89. And then 45 would be the next one. $45 is not the same. Weird. Maybe we just make it run until our expected solution is correct, and then we know. We also need to figure out one where the right modulo matches. Yeah, let's figure out what our solution is here and whether it's correct. So we know the period. The period equals the length of a line. Oh, we actually have this here. Yeah. So Longhorns, hello, welcome. Don't need priv here. And we basically want to... What? We need to get 3 numbers? Hey! Bought real good there. We need to be at least at 44. If land points is greater than or equal to 44. We need to get the ones... So we need to be negative 12. Okay, let's try, instead of 400, we're gonna set it to 100. Getting outside of range. Oh. Done Salamanca Breaking Bad. Hello, welcome. Solve is not defined. What did I call it? Solve. Quadratic. Oh, I forgot to put in a little S string there. Okay, so it starts being able to predict it after 59? Seems not what I expect. Don Salamanca Breaking Bad says, bro, why are you using 2 keyboards? Bro, why not? What if we do it for the big input? But bigger. Why did the big input go so much faster than the small input? Oh, because we never started to try solving, maybe? Again, twice as fast. Okay, what was the width? 130? It's pretty far out to find a repeat. Looping next. But that's fine. So then how do we figure out which equation we care about? Once we know it works, we need to progress forward. How many more? Steps minus mod width? we're just trying to figure out the right equation. Yeah, once we have the right equation, we can just plug in the number and we're good to go. A times I times I. Or wait, A times steps plus B times steps plus C. Theory. So what was one of the big ones for the small input? Big ones for the small. 5,000 and this. I guess we can say if we hit I, then we're done as well. Points. Need annotation. Oh. Ish tuple int. Incomplete dice assignment. Expression is type fraction. Variable has type stir. What the fuck? How did you get stir? Oh, because we have C up here. Okay, we'll call you A and B and C. That fraction. F. No. No. Oh. We got fraction out. Red dot denominator equals run, return numerator. Okay. Let's get rid of the prince. Oh, it's chugging away. We got it! Oh, thank goodness. Day 11, part 2. Day 11, day 21, part 2. What? Oh yeah, brain empty. I'm gonna go take a break before we come back for the final day. Sweet. Sweet. All right, we got all the stars going into day 25. So I will see you back in 2.5-ish hours. I guess I'll still do my little spiel. My name is Anthony. I upload educational content to my YouTube channel. That's youtube.com/anthonywritescode. I also upload to the VODs channel all of my stream VODs. They don't go up on Twitch due to DMCA shenanigans, so look on the stream VODs channel. I normally stream Mondays and Saturdays. And I announce on the Discord, which you're free to join. Come hang out with us. This is a beginner's channel if you want to ask questions. A bunch of other fun social channels, and yeah, a bunch of smart programming people there. So go stop by and hang out. Oh no, I didn't record this VOD at all.